50 microns selected some galaxies with the NEP field. Okay, please start.
Alright, nice to meet you everyone. I'm Hyunjin Shim from Gyeongbuk National University, Korea. The title of my talk was given like properties of 850 micron selected galaxies in the NEP field, but the survey is still ongoing, and as you saw in Sangjin's slides, it's less than 50% completed. So I will briefly show how the status of the SCUBA 2 850 micron survey over the NEP area, and we are going to do next. So the former PI of this NEP large program for 850 micron was Professor Hyunjin Lee. Unfortunately, he couldn't come here, even if he wanted. So the purpose of getting 850 micron in sub-millimeter is to add the far infrared to get some more points in far infrared data range. In addition to the Herschel sources and the Akari mid-infrared data points. So you see a lot of different SED shapes of starforming galaxies or infrared galaxies. So depending on the dust temperature and the ISM properties, there could be a deviation in the far infrared points, the far infrared data wavelength range. So we need some millimeter data to constrain the ISM properties of these bright galaxies. And if you go to higher versions, there is a big benefit of negative K correction of these galaxies. So if you see a typical ULARC, which has infrared luminosity larger than 10 to the 12 solar luminosity, you would expect the flux density change as different ratios like this. So if you observe the galaxy in the shorter wavelengths, if you go further, you will see a very faint, the galaxy gets really faint. But if you move to the 5 infrared to the 500 micron to 850 micron, you will see that the flux density remains actually the same between the redshift 1 and redshift 3, which means that if you observe in 850 micron, you will get ULARCs in redshift 1 and also redshift 3, so you will not lose any sensitivity, you will not suffer any sensitivity limits for these galaxies. So the survey was done in James Clock Maxwell Telescope with SCUBA 2 instrument. So the JCFT is now being operated by the East Asia Observatories, consortium of core observatories in East Asian region like Korea, China, Taiwan, Japan. So almost half of the JCFT time is offered to a large program, not by the individual PI program. So the large program is actually defined as a large program that exceeds total 200 hours exposure time. So this is to promote collaboration between the astronomers in especially the East Asia region, and also the original JCMT founder, the UK people and the Canadian people. So the JCMT selects the large programs for once, several, 2 or 3 years. So NEP was selected as one of the large programs in February 2017, so it has been 2 years after that. But it was ranked as a rank B program. So rank B is not guaranteed to finish between the certain period. And this large program period is to 2017, 18, and 19, like this year. So we will have chance to get more data in NEP region until the end of this year. So if we cannot finish the survey by this year, maybe we have to ask for the extension. So the next call for proposal for the large program will be announced in September. So maybe we have to discuss about the continuation of this project later in some discussion sections in this conference, and maybe we can discuss in later today or Wednesday. So the survey strategy is to cover the entire NEP wide area with the 850 micron with a very modest depths of aeronautic RF sensitivity, all of that negative light. You will see the very familiar shape of the NEPY survey right here, and the clover 4 circles in the HSC hypersurface cam data. So we will do covering the existing 0.6 degree A50 micron on the NEP dip by adding more and more pointing like this. So with the single dish scuba beam, you will map these like this. So in the center, there is a dip with a very good sensitivity, and if you go outer, the sensitivity goes bad. So you will get some fairly uniform sensitivity around this 30 arc-minute diameter circle. So we will observe it in the weatherband 3. So weatherband 3 is kind of a slightly bad weather in the Mauna Kea. So the execution or the completion of the program actually depends on the selection of the weatherbands. So currently we have 42% has executed. So this was actually the original S2CLS data obtained by 2017. Actually, the observation was made in 2014 and 15. So now we are expanding the area like this. So as you could see from the animation, the depth in the center was like in this level, and after adding this, you will see this gets more proper and proper. So we will go deeper and deeper in this area, and we are expanding this with a less sensitivity. So the actual noise level is like this. So the light gray one was the S2CLS data over the NEP dip area. So now we are having like this. So this means for this 0.6 degrees, we could go deeper by 2 times by adding this large program data. And about the sensitivity of the S2CLS depths, we increased the coverage by 1.5 times. And then we will get more data with less sensitivity. So briefly, the confusion limit of the A50 micron with a single dish observation will go like 0.8 millijoule per beam. So it will be not easy to go down to the confusion limit, but we will have a modest depth of this sub-millimeter data. So data reduction is undergoing, and we actually finished data reduction of the currently obtained fields. So this follows the basic or the conventional process for the sub-millimeter data reduction. So we did a lot of quality checks using the Monte Carlo simulations of the artificial images. So after subtracting the randomly mosaic images from the random mosaic images, that will produce a source-free noise map. So that's the Z9 noise map. And adding the artificial sources, with the assumed flux density distribution, then we will probably could make an artificial image that we know the flux densities and we know the original position that is given. And then after the source, with the artificial images, we do source detection to check the quality of the images. So this shows that this is just a pixel number distribution by showing the pixel flux results per beam. So you could see the solid lines are from the actual flux density map, and the shaded regions are pixel distribution constructed from the noise map. So actually this noise map pixel distribution follows Gaussian noise distribution, and there is a tail in this positive end. So that actually means that there is a source over here. So basically this vertical line could be considered as a flux limit that can be detected in the sub-millimeter data. So during the quality check, we should consider flux boosting by the statistical variations, and there could be a confusion from the and then the faint sources contributes to the central sources. So there could be a lot of flux boosting. So the flux boosting factor, the ratio between the observed flux and the actual injected flux, should be calculated, and then the observed flux should be corrected using this boost factor. So I'm not still satisfied with this flux boosting factor calculation, so we are still working on this. So this could be checked as a function of the better signal-to-noise ratio. So we could see the flux boosting factor affects to sources with the signal-to-noise ratio less than 5. And there is a positional accuracy of the 4 arcseconds. So this could be, by first sight, it could be considered as a matching radius, but there could be more, a lot of things more that should be considered in the actual identification. So there is a completeness, and the first source resection rate also calculated the signal-to-noise ratio and the flux. So currently I made a blind catalog of 850 microsources using source extractor. So by giving as a signal-to-noise threshold like 3 sigma, 3.5 sigma, 4 sigma, blah blah blah. So the flux density seems to be okay compared to the S2CLS data. So we are still improving the catalogs. So you could see this is the optical HSC images, color composite, and the Herschel sources, and the 850 micron SCLA2 images. So as you see, you need to identify which of these lots of sources are responsible for these sources. So yeah, some of the this is a quick, dirty cross-identification between the claim catalog from the HSC people with the object respect Z 1.1 and 1.46. You will see these are both at redshift above 1, and there is a large variation in the mid-IR to IR wavelengths. Alright, so we have a lot of things left. So this can be discussed in the discussion section, because the large program call, the next call is available from September, so we should discuss, shall we go deeper or shall we just expand the coverage? So we should decide which strategy we should take, and then we should plan for writing a proposal. And there could be a follow-up proposal. Actually, there has been some optical proposal by Korean side, but we can go another proposal by radio or CO, blah, blah, blah. And there is also a science side, so what we are going to do with this variable data. All right, thank you.
Could you remind me the data from S2CLS? What's the field? Who owns the data? How does it help for NEP? Is it overlap?
S2CLS is a SCLA2 cosmological legacy survey.
Okay.
So it's all public now. It's done by UK side with the SCLA2 implementation. So the survey has the images of several famous cosmological fields, including Akari NEP, Cosmos, UDS, EGS. Yeah, I think that's it.
Okay, because don't care about the other ones for now. So it goes pretty deep in the region of NEP?
NEP deep, only for 0.6 scale degree.
The central part she was
Yes.
showing at the beginning is from S2CL, and then we're extending it
I
around
understand
it.
now, thank you.
The central part.
So,
So that's it there.
Yes.
And it says it already reaches, when you say 1 millijansky, that's 1 sigma.
Yes, 1 sigma to 1.2 millijansky.
So what's the prospect of the finishing this survey? So obviously we need to think about next proposal as you mentioned. So before the proposal call or end of this year, how if data taking is continuous at this rate, how much data are we going to get?
Actually, we never know how the progress will be because whether the observing log will be assigned or not depends on the weather and it depends.
Right. Yeah. For assuming the current rate for the last 2 years. Yes.
So actually, from the February, the progress rate was really high.
Good.
So I think if we see the optimist, if we are optimistic, we will probably get to 60%, at least 60%. But that's my
Okay,
guess.
45 to 60%. So it doesn't really change the proposal.
Yeah.
Just fill in the number at the end. But there's no question we have to do this proposal.
I agree. Yes.
It just has to be.
One last comment. I think this data is very, very important because our Herschel data is shallow. So we have Herschel data only 10% of our Akari sources. The rest we don't have far infrared. But Scuba 2 can go much deeper than Herschel. So this is very important to have far infrared data for not all of them, but more of our Akari sources, I think.
Can I just add a very quick comment?
Yes.
Because every large programs are producing white paper now. If you really want to get the data, you have to write a white paper.
Oh, actually, the JCMT white paper is not for every large program.
Well, it's not for the proposal, but I mean, Transient is doing it, Vistro is doing it. It's better to secure your position right now.
Yeah, I know that they are collecting white papers about some millimeter galaxies, so maybe we could submit.
If you already have something in hand.
So, sorry, could you elaborate more? Is this white paper to submit to JCMT?
It's not clear how they are going to use it, but it's apparently linked to the new instrument.
Okay.
So it's,
It's because
Okay,
they are
thank you,
building
thank
a
you.
new
it's
mapping
political, I
camera.
think.
Okay.
Yeah.
Well, if we're going to write a proposal, I mean, we can just cut out science part.
Right, exactly.
Yeah, but actually the white paper is due to the end of the June and the proposal is in
Yeah,
September.
We still have 1 week.
We still have 10 days.
Sorry.
Okay, so this is a question.
As I comment, the LMG telescope in Mexico decided recently that they're going to do part of their public program also on the NEP.
Cool.
So that would be, I talk about it a little bit in my talk. It will be imaged in 3mm bands to 0.25 milligauss with a very good PSF. But of course not 850, right? So this is another argument for why it would be important to go even wider than just the 4 square degrees. To have another wavelength there.
Good point.
Yeah, that's good.
Is this data going to be public or public?
Yes, it's a public survey. They'll
Wow.
sit on it for a while until they finish, and then they'll. But anybody can join their team. It's just signing up. I did it, for example. I have nothing to do with the survey.
Oh.
And then this is because the NSF has partly paid for this Toltec instrument that they're putting on.
Oh,
So in return, they have
Public.
promised to do some public surveys, and this is one of them. So they're going to do an ultra deep survey of about 1 square degree in cosmos and candle fields, and then they're going to do this large scale structure survey, which is something like 40 or 50 square degrees in total, and 10 of them are going to be on NEP.
Whole NEP wide region down to a quarter of the jets.
Yeah. And you have there's a 50-meter telescope, right? So the PSF beam is very small.
It sounds like the ultra deep will be completely confused. Confusion.
It's going down to close to the confusion
Yeah,
level.
but that's not.
So that's going to get all lurks at all restricts, right? And
You can figure out which one it is.
well, you can because of the small beam. It's a 50-meter telescope, so the beam is only a couple of arc seconds.
Okay, so maybe you could discuss
What?
more.
So what's the time scale?
Well, supposedly there should be first light this year, but the rumors are that it's not really working.
The maybe. Okay. Thank you. Thank you.
Let's not skip again. So next talk is a open forum.